Hi, and welcome to another video on object-oriented programming in C#. With me, Marinas Toman. Okay, so in this video we're going to look at just a short introduction to classes and objects in C#. So looking at the Microsoft documentation first, let's see what they say about classes. So the definition of a type, a class, is like a blueprint that specifies what the type can do. So an object is basically a block of memory that has been allocated and configured according to that blueprint. And this article provides an overview. So the first kind of main concept that we got to understand is encapsulation. So encapsulation is sometimes referred to as the first pillar or principle of object-oriented programming. So if you think about encapsulation, it's like a container that you can put all of your different functions and pieces of your properties and your attributes for your classes. So a class can specify how accessible each of its members is to code outside of the class. Methods and variables that aren't intended to be used from outside the class can be hidden to limit the potential for coding errors or malicious exploits. You know, so people using your code as you haven't intended. So encapsulation, this is really the main reason that we have classes or classes and objects in object-oriented programming. So an object can represent a real-life object, so something that occurs in the real world. So just look at what W3 schools say. You know, they usually have a simpler explanation. So procedural programming is about writing procedures or methods that perform operations on data, while object-oriented programming is about creating objects that contain both data and methods. So if we look at an example here, classes and objects are the two main aspects of object-oriented programming. And if we look at this illustration, so in this example, the class here would be a fruit, and the objects that could be of type fruit would be apple, banana, mango. So an object is really an instance of a class. So a class is like a generic blueprint of an object, and then the object is the concrete implementation of this blueprint. So fruit would be the generic type, and then the actual implementation of the fruit would be an apple or a banana or a mango. Another example would be car. So you could have a blueprint for a car. You know, a car has so many wheels, it has so many doors, it has functions, you know, like drive, stop, things like that, change gear. So you could create a template for, you know, given things that a car can do, and then your object would be the implementation, so the actual implementation of one of these object or one of these types. So Volvo would be a type, or Audi type of car. So really in the real world, you know, real world is made up of objects, of real life things. So in programming, this is really more of an abstract way, or more of a high level way of looking at, you know, how we can program things about the real world. So instead of just, you know, storing data about something, we can actually have, you know, like we seen in previous videos, we can have methods to do different functions, as well as our data that we can store. So the member of a class then is everything basically that we can store inside a class. So members of a type include all methods, fields, constants, properties, and events. So in C# there are no global variables or methods as there are in some other languages. So that means that even the entry point, the main method, must be declared within a class. Okay, especially, you know, you have to do it implicitly when you're using top level statements, but of course that doesn't apply to us. We're not using them. So this list here shows all the different kinds of members that you can have in a class. So you can have fields, constants, properties, methods, constructors. Some of these won't be familiar to you yet, but we'll be going through them as we get through the semester. So members are basically the things that we can encapsulate into a class. Okay, so if you think of a class as one big block of memory, or an object is an instance of a class, the class is the blueprint, and then whenever we create an object, what happens is that block of memory has things encapsulated in it. So it can have fields, methods, all of these different things. So we can start to make our computer programs a lot more complex and safer as well, because we're hiding certain things from the user of our system or of our class. So everything C# is associated with classes and objects, along with the attributes and methods. So for example, in real life, a car is an object. The car has attributes such as weight and color, and methods such as drive and brake. So the class is like just basically an object constructor, so something that you can build an object out of, or a blueprint for creating objects. So it's like the outline of what an object should have, and then you actually need to put in the specific details whenever you're creating the object. So looking at how do we create a class, so we've seen already, Visual Studio's been creating these console applications. When we've been creating them, it's been creating these classes for us. So usually, just a default class called program, Visual Studio will create. But we can, with the keyword class, we can create our own class. And remember, the classes should always start with an uppercase. Okay. As it says here, it's not required, but it's good practice to start with an uppercase first letter when naming classes. And when a variable is declared directly in a class, this is what we would call a field or an attribute. So if this was a class person, then an attribute could be their name or their age or their height. Okay, so this is simple enough. We can declare a class and everything inside the curly braces, and then we can start to put in our members here. So different members like fields. So what if we wanted to create an object then of this class? So we've already created this class car, so now just let's use some of the create an object from it. So as you can see here, car just has one field, string called color, and down here we create a new car. So this variable my object is of type car, and it's just calling this default constructor. We look at constructors later this week, and then whenever we do this right line my object.color, it's just going to give us what is whenever we use the dot notation, we can access the variable or the field color. And as you see, when we print that out, it's just red. Okay, so yeah, as they say, we use the dot syntax to access variables, fields inside a class. This also is the same for methods. So variables, fields, methods, basically any kind of member inside a class. This is any kind of public member. We can use this. So what about if we want multiple objects? This is where it really starts to become obvious why object-oriented is powerful as a as a programming paradigm, because we can create one blueprint and then we can have multiple types of that object. So we can just create, this is what a car should look like, and then we could, that would be one class car, and then we could have a million instances of car. Okay, so we could create a million different objects. So in this case, it would just, every object would just have this. If you open that piece of memory, this piece of memory here, it would just have two members in it. It would have this string and then this method here, the main method. Well, actually, because this is, we can talk about this later, but because it's a static keyword, they don't actually get a copy of that. So yeah, if we want to, it's basically just the same. You just have to have unique variable names, and then this will print out red and red. So if we wanted to use multiple classes, so this is normally not the way that we would do it. So the way we would normally do this is we would break it up into basically your library or your class, a folder with all of your classes, and that's what we would call the library. And then we would have, our main method or a tester programs somewhere else, in a different program completely. So this is even safer because this is, like we said previously, we want encapsulation. So we want this thing to be hidden from the user. We only want things that are public to be seen. So whenever this is called here, this is a public field, so we can access this pretty easily. Okay, that's pretty much everything. So yeah, we'll talk about access modifiers in the next video. So we'll just skip that for now. So if we look here, fields and methods inside classes, this is what members are. Okay, so as we see back here, fields, constants, properties, methods, constructors, basically everything inside a class is going to be what's called a member. So in this instance here, we've got two fields and one method. So in total, we could say this class has 3 members. So in the previous chapter, we learned that variables inside a class are called fields, and you can access them by creating an object of a class and using the dot syntax. So we could see here, we could create, an object of this class and then just go dot color, dot max speed, and we would be able to access it. So as you can see here, you could also leave the fields blank and modify them when creating the object. So you could, create an object here, and this would be these fields would be blank, but then you can initialize the values after the object's created, and then same again, this is going to output these values. And then so this is where we can see, when we're creating an object of a car, every car is going to be different basically. So it's going to have its own fields, it's going to have its own properties. So each car will have the same structure and the same look, but the actual example or the actual instance of it will be different. So you can see this car is red, the next one's white. Every car will have its own color, every car has its own model, every car has its own year. So if we looked at this, let's say we took this car class, we have a string color, an integer max speed, and then they're just set to some default values, and we can write them out the line. So that's what we'd be saying, red and 200. But what we could do is we could add another method here, another member. Let's just give it a public keyword so we can access it from outside the class. It's got a void return type and its name is drive. Okay, and then that means whenever I create this object here, it has this dot drive method, or this drive method that I can access with the dot syntax. And then if we wanted, let's say, to put when I called this, you can see the output here would just be print this to line. So it would just call that method and do whatever. So if we wanted add, let's say, another field, and we could change it inside any of these methods while inside the class. So then we could check it then from outside, so check in this variable or this field outside, and you could see that after, so it starts false, after I drive it should be true, and yeah, we can see it has been changed. So that's another good thing, you know, you can change these fields while inside methods as well. Okay, so the methods, so when we looked at methods last week, we seen that, you know, they can perform certain actions. So they normally belong to a class and they define how an object of a class behaves. So just like with fields, you can access methods with the dot syntax, so just like I showed you there. However, note that the method must be public. So if it's not public, we can't get access to it from outside the class. Now this example is okay because, you know, my method is inside the class here, so I could have left that public keyword out, but we put it in if we want this to be accessible by outside the, from outside the class. So we'll again we look at the accessor keywords and what they're all about, the access specifiers in more detail later. So let's say we wanted, you know, we wanted to use multiple classes. So you could see here that we have 4 members in this car class, and then in our tester program we're creating 2 different instances. One's called Ford and the other's called Opel, and we set some instances to that, and we can see then what model. You know, we're just typing out what is the model, and you can see they're both different. So yeah, we will talk about the accessor keyword later, but as you can see, the main benefit is that we can use multiple instances, or we create multiple objects of the one class. So this is where it really becomes powerful, you know, when we start putting that together with loops and things like that. Yeah, you can see where the object oriented concepts really become, you can see why we're teaching you about this and why it's so important in programming, because it really is a paradigm shift from the kind of older ways of doing things. Okay, so that's everything for the video. Thanks for watching.